of roots. How do we define nature of roots of a quadratic equation? To answer this question, let's consider a quadratic equation in its standard form. That is, ax square plus bx plus c equal to 0. We know that roots of a quadratic equation can be found using the quadratic formula. That is, x equal to negative b plus minus square root of b square minus 4ac over 2a. Using the quadratic formula, the value of x will be this and this. The expression of b square minus 4ac plays a very important role. This expression is known as discriminant. The value of discriminant defines the nature of roots of a quadratic equation. There are three possibilities for the value of the discriminant. It can either be greater than 0, equal to 0 or less than 0. Let's study each case one by one. If the value of the discriminant is greater than 0, then its square root will be a real number. Thus, the value of x will be two real and distinct numbers. Let's consider an example x square minus 2x minus 3 equal to 0. Here, a is 1, b is negative 2 and c is negative 3. So, value of discriminant is equal to negative 2 square minus 4 into 1 into negative 3. On solving this, we get 16, which is greater than 0. So, using the value of discriminant, we can find two roots of the quadratic equation. And we can see that the roots are real and distinct numbers. In the second case, if the value of discriminant is equal to 0, then its square root will also be 0. Thus, the value of x will be two real and equal numbers. Let's consider an example x square plus 4x plus 4 equal to 0. Here, a is 1, b is 4 and c is 4. So, the value of discriminant is equal to 4 square minus 4 into 1 into 4. On solving this, we get 0. So, using the value of discriminant, we can find two roots of the quadratic equation. And we can see that the roots are real and equal numbers. In the third case, if the value of discriminant is less than 0, then its square root will not be a real number. Thus, the value of x will not be real numbers. Let's consider an example. X square minus x plus 1 equal to 0. Here, a is 1, b is negative 1 and c is 1. So, value of discriminant is equal to negative 1 squared minus 4 into 1 into 1. On solving this, we get negative 3, which is less than 0. So, using the value of discriminant, we can find two roots of the quadratic equation. Since we cannot find square root of a negative number, so the roots of the quadratic equation will not be real numbers. Let's quickly sum up what we have learned. For a quadratic equation, ax square plus bx plus c equal to 0, if the value of discriminant is greater than 0, then the quadratic equation has two real and distinct roots. If the value of discriminant is equal to 0, then the quadratic equation has two real and equal roots. If the value of discriminant is less than 0, then the quadratic equation has no real roots. These are the nature of roots of a quadratic equation.